In order to properly design a production line effectively, you're going to want to identify 4 variables. The first one is the resource node type, which is going to tell us how rich the node is and thus affects our resources pull per minute. The miner that's being used, in this case we have an MK1, but you can go to MK2 or MK3. This affects the gathering rate. The conveyor belts that are available to us, in this case we have some pretty high conveyor belts, but for this example we're going to be assuming that it's MK2 conveyor belts, because you can see in the description here, transports up to 120 resources per minute. If this is not greater than or equal to the gathering rate, it becomes a bandwidth issue. So if we were to use conveyor belt MK1, which is only 60 resources per minute, that's going to be a problem, because if you look at here, our resource pull is 120 coal per minute. So we cannot use MK1s because that means we're leaving resources on the table. So we need at least MK2 or higher. And then lastly is the rate at which the resources are being consumed per building. So let's go ahead and take a look at a coal generator, because that is exactly what we want to use this for. And a simple way to check that out is to go over here to the infographic and see that coal is burnt at 15 per minute. So with simple math, we could see that we have 120. So all we have to do is divide 120 by 15. And that gives us 8 coal power generators running at 100%. So that is exactly what we need to set up. So we're not going to be setting up here. We're actually going to be pulling this coal somewhere else. So with these 4 variables identified, you can effectively design your production lines to ensure maximum potential. Just a few notes. In this example, we're just using MK1. We're not going to be overclocking it as well with any power shards. We're just going to be using the 120 per minute. If you increase it or decrease it, it's up to you. You just have to change the variables based off that. So here we have our example of our 8 coal generators that we determined earlier from our quick math of 120 divided by 15. We got our 8 coal generators. The big thing here is properly setting up your conveyor splitters. These things are taking an input and splitting it evenly to all the outputs that are connected. So in this case, we have 3 outputs. So if you look at this, we have 120 coming in here and then splitting into 3, 1, 2, 3. So that should mean 40 goes here, 40 goes here, and 40 goes here. It's a pretty easy math. But if you continue that, if you split 40, or if you're splitting 120 into 40, and that 40 goes here and gets split again into 3 different ways, well, now you're getting a fraction of a fraction. So this is where you have to be careful and make sure that when you're splitting your conveyor belt lines, you're not daisy chaining them. And what I mean by that, say if we go to our example over here, you can see that we only have 2 splits. So 120 coming in goes 60-60, right? Well, this 60 goes over here and splits into 3 different ways. So you have 20, 20, 20. But then wait, this daisy chain also takes half of this. So what is now 20 is going to 10. Well, now we have another 10 getting split in half. So 5 and 5. So as you can see, if you daisy chain stuff, you're effectively making the outputs that are on the lower end of the branch smaller and smaller. You don't want to do that. Ideally, you want to split evenly from the highest point possible and sprinkle it downwards. Now looking here, we only have 2 outputs in the middle because there's only 8. If there was a 9th, we could put one in the middle to have all even splits. But in this case, we have 40 getting split into 20 and 20. But wait, Jax, didn't we determine that earlier that this is going to be using 15? You are correct. With that being said, that means that there's going to be a backup eventually that occurs. And where does that backup go? Well, it's going to be split down over here and here. Because if we do some math, if we got 40 going this way and we split 43 different ways, that's 13.33. That's obviously not going to work out for these because these are going to be taking 15, right? So there is a bit of equalization that has to occur when these start to build up, but it will happen eventually. Now, there are 2 schools of thought on whether or not you should go 8 or 9 generators. If you want to keep things simple and avoid overcomplicating your design, 8 generators is going to work just fine. You might have some minor overflow issues, but it's going to balance itself over time, as we showed right here. These will eventually overflow and split into the other output. But for most players, That is not a big deal. But if you want to squeeze out every drop of efficiency, you can go with 9 generators. You just have to downclock them. This ensures that the exact usage of 120 coal minute with no excess. It takes a bit more setup, but it's cleaner and perfectly optimized solution. Now you're probably wondering, how do you determine the downclock? Well, it's actually pretty simple. All we have to do is take 120 divided by 9. And what that gives us is 13.33. And if we take 13.33 and use a bit of math to find relationships between the two, you'll see that if you solve for x, you'll actually get a downclock of 88.87% if you round up. So if we input 88.87% on all of these, I'm not going to do it for all of them, but if we just put 88.87, you'll see that the target changes, so it's going to be using less water and it'll also be using less fuel. Again, it's up to you how you want to do it, but either way is completely valid, especially for simple setups like this. Well, that's all for this video. Now that you know how to optimize production from the resource node itself, in my next video we'll be tackling the opposite approach, designing around an end product goal for even more efficient production line chains. If this helped you, go ahead and drop a like, and if you want to see more master factory efficiency, hit that subscribe button. It helps the channel out a ton. And as always, I'll see you next time, and have a good one.